So in this session, we'll look at our neural network architecture again. I remember we started this from the third or the fourth video. And in that video, we talked about our constructor. So this constructor encapsulates the weights at the first stage and also the weights at the second stage. So the weights at the first stage, then the weights at the second stage. And then you can see we did this earlier. So what I did was to put all of this in a train function. So this function would help us train our architecture, our neural network, the weights in our neural network. And you see that this function takes in two parameters, the input data as well as the answer. So for example, looking at our loan Excel sheet. So these are the inputs. So these are the inputs. You can see these are the inputs. And then this is our target, our answer. So that means this train function takes in the features as well as the corresponding answer. And then, so that goes into that function. And then what we did here was to also convert, to tilt or to transpose that data. So you can see this data looks like this. You can see it's a 1 row, 7 columns. So if we were to reckon with 3, 4, 5, 6, 7. So it's a 1 row, 7 column. We want to transpose it to 7 columns, 1 row, such that we're able to pass it into our model. You can see, let's imagine that our model looks like this. Our neural network looks like this. And then instead of having just 2 neurons here, we have 7. So, 1, 2, 3, 4, 5, 6, and 7. So you want to transpose it such that the first feature goes in here, second feature, third, fourth, fifth, sixth, and 7. You can see it now looks like 7 rows, 1 column, such that we're able to pass that through. And then we would have our target here too. So our target will be waiting for us here. So our target also looks like this. So in this case, for the first row, you can see we take all of this, 1, 2, 3. So we're going to drop this column. So we reckon with only 1, 2, 3, 4, 5, 6, 7, and then we transpose such that it fits. It goes in that 1 column vector, and then you have the answer waiting for us here, which is the target, which is 1. I hope this makes sense. So that is what we're doing here. We are transposing. So we're transposing. So this would be a 1 by 1. Remember, it looks like this. If you transpose this, it will still give, let's say your 1, let's say your target is 1, and it looks like this. It's still a 1 by 1, a 1 by 1 matrix, whereas this becomes a 7 by 1 matrix because it has 7 rows and 1 column. Yeah, so we transpose, and I'm sure, remember we did this earlier, the forward pass. So your weights will interface with the data. So what it means is that at this point, once you have your input, this input will also interface with the weights. And then, so we did this earlier, and whatever you have there before it exits from this layer, what happens? You would have to go through the sigmoid function. That's what we did here. So it goes into the sigmoid, and then you have the L1 output. So this one, at this layer, you have all the outputs now. So this is L1, that is layer 1 output, depending on the number of nodes you have here. And then whatever you have here too would also multiply the weights in the second stage. So here you have, so these outputs, just like have your O3, your O4, your O5, your O6, depending on the number of neurons you have here. So all these O3, O4 would also interface with the second stage weights. And then whatever you have to before it exits this N6, it will also go through the sigmoid function. So it will go through the sigmoid function, and then you have an output. So that's the first leg now, which is a forward pass. That means you are passing your data from left to right. That's the forward pass. And then the backward pass would go from right to left. And in the backward pass, we have, remember, you have your answer, which is your target. So to find the error at this node, to get the error at this node, you have to do your target, which is the correct answer, minus the output. And then you get the error at L2. So the error at layer 2. So that's the error here. You can see L2 error. And then remember, how do we now get the error? So this is backpropagation. You're trying to get the errors at this layer. How do we do that? Remember, we had a formula. How do you not get the errors here? Error EN3, now we have the error here, which is 044. And then how do you use this 044 with the weights here to try to find the contribution EN3, EN4, and EN5? And to do this, there's a formula. Remember this formula? You would use the stage 2 weights and then also the error here, and then you have to transpose this. So if I come here, you would find it here. You see? Yeah, the backpropagation. Remember this, we did this, that we had to transpose. So you can see T, you have the weights, W7, the weight at stage 2, W7, W8, you transpose it. In this case, it becomes a 3x1 column, and then that goes with the layer 2 error, which is EN6, that's the error at the output layer, which is 0.44. And then you do your matrix multiplication, this times that, this times that, this times this, and that would give you layer 1 error. And layer 1 error encapsulates EN3, EN4, EN5 from that, from this equation. EN gives EN3, EN4, and EN5. That's layer 1 error. So you have your layer 1 error. Okay, you have your layer 1 error. And then the next thing is to do what? So you've calculated your layer 2 error. Now you've calculated your layer 1 error. The next thing is also to adjust the weights. I mean, remember, so once you calculate the error here, the error here, the error here, depending on the number of neurons you have, the next thing is to see how much, and you also have the error here. Based on the error here and the output from the previous layer, you can calculate how much to nudge to adjust the W7, W8, W9. Based on the error here, the errors here, you can also use that to adjust, to find out how much you would adjust all of these weights such that these errors are reduced. So let's go back to our code. Yeah, so the next thing is to adjust, update our weight. And remember, we've looked at this equation. So let's go to lecture 14. And remember this. So remember this now. Remember we did something like this. Yeah, so if you look at, so what that equation encapsulates this part. And so we're here now. So if you look at it now, you have a dot product. You can see L2 error. You can see that is the error at the output times, you can see L2 output. You can see S also encapsulates the output, which is maybe input from the previous layer times W plus another input times W7, W8 sigmoid, and all that. So this gives that output that goes from the output layer. And that's your that's the L2. You can see it as L2. 1, you can see 1 minus L output at layer 2, and that's it. And then you would multiply, you do your matrix multiplication with, you can see now, L1, so output from the previous layer, which is your O2, I think, is it O2, O3, O4? So this is the output layer. Yeah, so yeah, O3, O4, O5, you transpose that, and that becomes a 1 row, 3 column matrix. Yeah, so once you do this, you would find how much to adjust W7, W8, or W9 as the case may be here now. So what we're now doing here, if you look at this formula, you will see that there's a minus here. Remember, and also there's a minus in front. This is your learning rate. Remember, we talked about learning rates. We're actually following this formula. And that is what you have here. That's the formula we are looking at. This you can see. Your old weight minus, there's a minus here. But if you look at it critically, this minus would cancel out the minus here. So all of this are your how much to nudge all of this now, encapsulate what you have here from this non-pi dot to the end. That's what you have. So that is how much you need to adjust your W7 times your learning rate. So there's a learning rate here. A learning rate that tries to control how much you're updating your weights. Yeah, so this is your old, so that's your old weight. So this is the old weight plus the learning rate times how much to adjust a particular weight. So you can see now that gives 0.1. So invariably, all of this would adjust the weights for W7, and then because it's a matrix multiplication, all of this W7, W8, W9 will be encapsulated in this stage 2 weights. So all the stage 2 weights would also be found under this variable. I hope this makes sense. Okay, then. So the same thing we did for stage 2 weights in terms of updates, we would also do the same for stage 1 weights. And remember, for stage 1 weight, we did something like this. So this is your stage 1 weight. You can see I've copied it here. And then if you look at it, really, so how much, if you look at, so all of these two encapsulate what you have here. So this is how much you need to adjust W1, W2, W3, W4, W5, W6. And then you can see, so L1 error. So you can see your L1 error. So these are your errors for, let's see that now. These are your errors, EN3, EN4, and EN5. So these are errors. So EN3 error, you can see. So L1 error encapsulates all the errors at layer 1, and you have EN3, EN4, EN5 multiplied by L1 output. Yeah, so output, L1 output. Where is L1 output here? So L1 output encapsulates O3, O4, and O5. These are the outputs at layer 1. That's what we did here now. And then, so these are the outputs, and S1, S2, S3. Remember, your S1 would mean, S1 would mean whatever you have here times this, W2, whatever you have here times W1, and then it goes inside into a sigmoid function to give you O3. So that is what is encapsulated here. Yeah, so, and then, so once you do that, you do your matrix multiplication, this times this will give you how much to adjust N1, and this times this, the input to N2 will give you how much to adjust N2. This times 3 will give you this. This times this will give you how much to adjust N4. And then this times this tell you how much to adjust W5, W6. So these are the weights. And so all of this, so this, yeah, you can see this could be for W1, W2, W3, and like that, like that, like that to W6. So that's what we calculated. And whatever we calculate would multiply by a learning rate. Remember, learning rate is just to ensure that we do not miss that global minimum. Yeah, so just to multiply, it could be 0.1, whatever, that you can experiment with different values. And then this minus would cancel this minus. That's why you have a plus here. Yeah, so invariably, stage 1 weights, this would encapsulate the new weights, because this is the old weights plus how much you want to adjust, and then the old weights would also, I mean, you have how much to adjust. So maybe at the end, maybe this is 0.001, and then let's say the old weight for a particular weight is maybe 1, and then 1 plus 0.001 becomes 1.001. I hope I'm right. Yeah, so that reflects the new weights. Yeah, so and then you do that for not only W1, you do that W1 up until W6. And that's what we did here. And once we have done the training, remember this training. So what happens is during training, you pass in a particular row. You find those weights are fine-tuned. So you pass in a particular row. The particular row will do the forward pass, will do the back propagation. That means getting the errors, adjusting the weights. So you're fine-tuning the weights. The next time it will pass in the second, we'll do this in the next video. We'll pass in the next row. The next row comes in, the next row, and then the answer to the next row. It does the forward pass with the new adjusted weights, and then it also calculates the error, and hopefully the error will have reduced at this point, and then you adjust the weights further, and then you pass in the third, and by the time you are done with all of this, all of these features, I think there are about 2,000 or so, the errors will have reduced, and then you're able to do some prediction. So I'll end this session here, and then we'll continue. Thank you very much.